In this video, I'm going to do exercise 9C questions 2 and 3 of A-level Pure 2 textbook. So this exercise is on chain rule, and let's just start with 2A. So let's call this function, let's write it as a function of f of x. So we have f of x, which is equal to e to the power of cos x. Now we want to differentiate this, and we need to remember that when we want to differentiate exponentials, and what happens is that here we need to differentiate because we are differentiating e. So e has a special property, which is you differentiate its power and then that comes down as its multiple. So cos x differentiates to minus sine x times the function again, e to the power of cos x. And that's it. Now let's do b. So this was a, and let's do b. So let's call this one y. Y is equal to cos of 2x minus 1. So we need to remember that when we want to differentiate cos of something, first we need to look at the inside of the bracket and see if it has a derivative. Obviously 2x minus 1 differentiates to only 2, so that will be the multiple which comes out, and so dy dx is equal to, so first differentiate inside, which differentiates to 2, times. Now here you need to be careful, because this time we keep the inside but we differentiate the outside. So outside is cos, and we know that cos differentiates to minus sine. So we will have minus sine 2x minus 1. And of course we can simplify this, which is equal to minus 2 sine 2x minus 1, and that's the answer. Right, c, so we have y, which is equal to a square root of natural log of x. So whenever you have a square root, it's better to write that in this form, natural log of x to the power of half, because this helps us to differentiate this. And now this is chain rule again. Of course it's chain rule because this practice is just on chain rule. So we first start by bringing this down, this power, which is a half, and then times. So now we need to multiply this by the derivative of inside to this power minus 1. So derivative of a natural log of x is just 1 over x. And remember that we have this power, which so times natural log of x to the power of minus a half. And we can simplify this, which gives us 1 over x times, or we can write that in this form, times natural log of x, square root of natural log of x on the denominator. Yeah, so we can simplify this, and that's the final answer. D. So we have y is equal to sine x plus cos x to the power of 5. This one is similar to the previous one, because we have a bracket and it's raised to the power. So first we start by, of course, writing down dy dx is equal to the power times the derivative of the inside. So sine x differentiates to cos x, and cos x differentiates to minus sine x, and then times times the bracket sine x plus cos x, but with the power minus 1, which is 4. Now we can simplify this, and this is going to be equal to minus 5 cos x sine x times sine x plus cos x to the power of 4. And that's it. E. Y is equal to sine of 3x squared minus 2x plus 1. So this is similar to B. We start by dy dx as usual. Now we need to find the derivative of the inside. So 3x squared differentiates to 6x. Minus 2x differentiates to minus 2, and 1 differentiates to 0 because that's a constant. And this times the derivative of sine, which is cos, and then inside, which is cos 3x squared minus 2x plus 1. And we'd better leave the answer like this. F, y is equal to the natural log of sine x. So we need to remember that these type of differentiations are actually very easy when you have natural log of something. So it's just enough to, you will have a fraction as your derivative most of the times. And as your numerator, you will have the derivative of inside. In this case, sine x differentiates to cos x. And your denominator is just inside, whatever you have inside. So in this case, it's sine x. And of course, by using your trigonometric identities, you can also simplify this to cot x. Right, so g is y is equal to 2e to the power of cos 4x. Okay, so this is similar to one of the previous examples that we did. So we need to differentiate the power. So cos 4x. So first, let's just write down 2 times the derivative of the power. So cos 4x differentiates to minus 4 sine 4x times the e to whatever power it has originally, which is cos 4x. And this can be simplified to minus 8 sine 4x e to the cos 4x. Now the last one, and again this is similar to two of the examples in this exercise. So again, we differentiate inside, and we have e to the 2x, which differentiates to 2e to x, because the derivative of the power is just 2, and 3 differentiates to 0, so we don't want that. And then these times cos, so cos differentiates to minus sine and inside, which is e to the 2x plus 3. And we can simplify this just to write it like minus 2e 2x sine e to the 2x plus 3. And that's it. Now let's do question 3. Given that y is equal to this function, find the value of dy dx at 1/4. Right, so we just need to differentiate y. So let's rewrite y as 4x plus 1 to the power of minus 2, so that we can differentiate this easier. And now we start by writing down dy dx as usual. So okay, so first we need to differentiate this, and if we want to differentiate this, the power comes down again, minus 2 times the derivative of the inside, which is just 4, because 4x differentiates to 4 and 1 is a constant, times inside again, the whole thing in the brackets, to the power of the power minus 1, which is minus 3. So let's simplify this. Minus 8 over 4x plus 1 to the power of 3. And now we just need to, because since we want to know the derivative at this point, now we need to substitute 1/4 into our derivative, because we want to know what is the derivative of this function when at this point, basically, or when x is equal to 1/4. So at x is equal to 4, dy by dx is equal to minus 8 over 4 times a quarter plus 1 cubed, which is minus 8 over, so here is 1 plus 1 is 2, 2 to the power of 3 is 8, which is minus 1, and that's it. So that's the derivative at this point. Okay, so that's it for this video, and thanks for watching. Make sure to subscribe for more videos. Good luck.